Hello guys. In the previous series we have solved Fourier series. Fourier series are of two type, that is even function as well as odd function. And today we are going to solve even function. If the function f of x is even in minus t to t with its period at 2t, then its Fourier series is given as f of x equals to a0 by 2 plus summation n equals to 1 to infinity square bracket open an cos n pi x by t plus bn sin n pi x by t. But there is a little bit twist. That is, here bn, the value of bn is equals to 0 since it is an even function, and the value of a0 is equals to 2 by t, not 1 by t, 2 by t integration 0 to t, not the full range, only the half range. That is, either you take a positive range or either you take a negative range. And function f of x dx, and an is given as 2 by t, not 1 by t, 2 by t, remember, 2 by t integration 0 to t, that is range, half range, not full range, half range. You either you take the positive range or you take the negative range. F of x, that is the function given in the problem, cos n pi x by t dx. Okay, now how to check whether the function is a even function or odd function? I will tell you how to check it. Now the condition for checking whether the function is even and odd is given as f of x is even if, first condition, f of x equals to f of minus x in the range minus t to t. That is, when we substitute x by minus x, we should get the same answer when we substitute the function as x. If we get the same answer, then the function is a even function. Second condition, if the graph of the function is symmetrical about y-axis, then the function is called as even function. Now getting towards the sum, for better understanding, the sum here is given as f of x equals to x square in the range minus pi to pi, and hence deduce that at 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus dotted equals to pi square by 6. And second, and that we have to deduce is 1 by 1 raised to 4 plus 1 by 2 raised to 4 plus 1 by 3 raised to 4 plus dotted equals to pi square by 60. Now for let's keep the reduced part aside. Now solving only the function, since we have to check whether the function is even function or an odd function. First we find the period. Here period, that is 2t, exactly 2t equals to 2 pi. Okay, first condition, substituting x has minus x, therefore f of x equals to f of minus x equals to minus x the whole square equals to x square equals to f of x. Now checking for the second condition, that is drawing the graph. since the function is x square, that is, it is the form of a parabola. Okay, and the highest value is pi square. Here comes minus pi to pi, that is the range. Okay, now moving towards, since graph is symmetrical about y-axis, that is the required condition we want for the function to be an even function. Therefore, the given function is an even function. Therefore, the Bn part will be 0. Now the function, the Fourier series, the function for the Fourier series will be f of x equals to a0 by 2 plus summation of n equals to 1 to infinity bracket an cos of n pi x by t dx, because the term bn will be 0. Now finding the value of a0 first, where a0, as we know that a0 is 2 by t, integration half range, that is 0 to t, f of x dx. Now substituting the value of t as well as substituting the value of function, therefore the value of t is pi, therefore a0 equals to 2 by pi integration 0 to pi, function is x square equals to f of x equals to x square dx, therefore equals to 2 by pi bracket x cube by 3 integrating x square, we get x cube by 3, and the range is 0 to pi. Now substituting the range, that is its upper limit minus lower limit, we get at a0 equals to 2 pi cube upon 3 pi, that is equals to 2 by 3 pi square. Coming towards the an part, an equals to 2 by t integration 0 to t f of x cos of n pi x by t dx. Now substituting the value of t and the function, we get 2 by pi t value 0 to pi, function is x square cos of n pi nx, that is since x is equals to since x is t equals to pi, therefore the pi term will be get cut here, and we get at cos of nx dx. Since this part is the we have to apply here, we have to apply integrations uv rule, and for that we know that at integration of uv equals to u v1 plus u dash v2 plus u double dash v 3 plus dot 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 dot. This is to be done till the u term, that is the differentiation term, gets equal to a constant. That is, if it is x square, then it should be to a constant, should lead to a constant. That is, integration derivative of x square is 2x. Then it then again derivating it to as x ka taking x ka derivative, we get 2. That is the constant part. Applying this UV rule to this, we get an equals to 2 by pi bracket x square, that is u part, taking it as constant, not changing it or not taking the derivative of x square, and integrating. The suffix here stands for integration, and therefore v1, the integration of cos integration is sine, therefore sine of nx upon n minus alternate sorry, remember that it always we have to take alternate signs in while integration UV rule. Therefore this will be negative. If now taking the derivative of x square, that is 2x, and integration of cos and nx upon sin nx upon n, that is integration of sin x nx is minus cos, therefore we get it minus cos of nx, the whole divided by n square, since one n from here and second n from here. Now plus taking derivative of 2x, that is 2, and integration of cos x, we get minus sin x, since minus here, nx upon n cube, there is n square here from n 1 n from here, and the limit is 0 to pi. Now since we know that sine of 0 equals to 0 and sine of n pi equals to 0, right? Therefore we get an equals to 2 by pi bracket 2 pi minus 1 raised to n upon n square, since cos of n pi equals to minus 1 raised to n, as we remember. The final value of n on solving is 4 minus 1 raised to n upon n square. Now substituting the value of n square and a0 in the Fourier series. His f of x equals to a0 plus an, that is a0 value is pi square, a0 value is 2 by 3 pi square, therefore 2 by 3 pi square plus summation n equals to 1 to infinity bracket 4 minus 1 raised to n upon n square into cos of nx. Now coming towards the derivative part. For first problem, that is we have to find 1 by 1 square plus 1 by 2 and 2 square plus 1 by 3 square plus dotted dotted x square by at 12, not 6 because it was wrong, and that is x square by 12 we have to prove. For that we put x equals to pi and cos us nx n pi equals to minus 1 raised to n. In f of x, that is pi, since x is equals to pi square, since it was x square, therefore pi square equals to 2 pi square by 3 plus 4 or summation n equals to 1 to infinity minus 1 raised to n minus 1 raised to n upon n square. After solving this is we get at the final value as pi square by 3 equals to 4 summation n equals to 1 to infinity upon 1 upon n square. Further, that is rearranging the terms, summation n equals to 1 to infinity 1 upon n square equals to pi square by 12 is the required answer or solution, and that is 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus dotted dotted that equals to pi square by 12. Now for the second part, that is 1, that is 1 by 4 plus 2 by 4 plus 3 by 4 plus dotted dotted equals to pi raised to 4 over upon 90. For that we have to use an identity known as the Parseval identity. The Parseval identity is given as 2 by t integration 0 to t f of x the whole square dx plus equals to a0 square by 2 plus summation n equals to 1 and to infinity an square. For that means we have to square all the terms, that is f of x, a0 and an. Now the f of x value is x square as given in the problem, and a0 value that we have found out is 2 by 3 pi square, and the an value that we have found out it is 4 minus 1 raised to n upon n square. Now substituting this value in the problem, we get at 2 by pi as t is equals to pi at 0 to pi integration and pi x square raised to 4 or dx equals to a0 value is 2 by 3 pi square the whole square upon 2 plus summation n equals to 1 to bracket 4 minus 1 the whole n upon n square the whole bracket it square. Now for the solving on we get at that is 2 by pi bracket integration of x raised to 4 is given as x raised to 4 is given as x raised to 5 upon 5, but after substituting in the limits we get at pi raised to 5 upon 5, since the 0 part will be 0 equals to 2 by 9 in pi raised to 4 plus 16 summation n equals to 1 to infinity 1 upon n raised to 4. On further solving, we have to put that at minus 1 raised to 2n equals to 1 for this part, as you can see equals to 1. Therefore 2 by 5 pi and this pi raised to 5 equals to 2 by 9 pi raised to 4 equals plus 16 summation n equals to 1 to infinity 1 by n raised to 4. Now here we will cancel and get 2 by 5 pi raised to 4 minus 2 by 9 in pi raised to 4 equals to 16 summation n equals to 1 to infinity 1 upon n raised to 4. On further solving this part by taking LCMs we get at 8 by 45 equals to pi raised to 4 equals to 16 summation n equals to 1 to infinity 1 by n raised to 4. Cutting 8 ones and 8 twos, therefore taking these two in the down section we get summation summation n equals to 1 to infinity 1 upon n raised to 4 equals to pi raised to 4 upon 90 is the required solution. That is 1 by 1 raised to 4 plus 1 by 2 raised to 4 plus 1 by 3 raised to 4 plus dot 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 equals to pi raised to 4. Always remember that when we have to take the power as something raised to 4 or greater than 2, we will always use Parseval's identity for that problem and never make a mistakes in these parts. So like this video, share this video with your engineering friends and subscribe to our channel. Thank you.